My name is Etse-Campbell from the University of Texas at Austin, and I'm here to present my paper, A Novel Method and Device for the Delivery and Retention of Intrauterine Devices in the Immediate Postpartum Period. The immediate postpartum period presents an ideal time for an IUD insertion procedure. The woman is definitely not pregnant, conveniently co-located with her clinician, and most likely desires effective contraception to prevent an unplanned pregnancy, which typically occurs within the first year postpartum. When this happens, this short interpregnancy interval has been linked to an increased risk of fetal and maternal morbidity, for example, intrauterine growth restriction, spontaneous preterm deliveries, preeclampsia, just to mention a few, and mortality. The American College of Obstetricians and Gynecologists has suggested that immediate postpartum contraception affords an effective solution to reduce such morbidities and mortalities and to achieve reproductive life goals. They additionally recommend the immediate postpartum IUD insertion procedure. Unfortunately, because up to 30% of IUDs inserted using this procedure are expelled, rendering the contraceptive ineffective, the procedure is underutilized. Our objective, therefore, was to design, fabricate, and evaluate a novel IUD insertion retention device by tethering a commercially available T-shaped IUD to the uterine fundus of an immediate postpartum baboon. And this non-human primate was selected because of the anatomical similarity of its reproductive tract to that of humans. And this is the device that we developed. Our unique device consists of a helical needle attached to an IUD housing tube and activated by rotating its knob on the end. The introducer tube shields the helical needle from coming in contact with tissue other than the targeted uterine fundus. We attached an intracorporeal absorbable barbed suture to a T-shaped IUD and threaded the suture into the helical needle. The introducer tube is used to locate the attachment point on the uterine fundus. The helical needle inserter is advanced to the fundus through the introducer tube. The suture is deposited in tissue by rotating the knob. Upon device removal, IUD and suture tether are secured. When the uterus contracts during involution, the suture tether ensures the IUD remains in close proximity to the uterine fundus. For the pilot study, our unique device was used to deliver suture tether and attach IUD to the uterus of an adult postpartum female baboon using ultrasound guidance. At week 3 following the procedure, hysteroscopy imaging confirmed the absorbable suture still tethering the IUD to the uterine fundus. At week 6, ultrasound imaging showed the IUD central stem completely within the uterine canal, with its arms extended laterally at the uterine fundus. In summary, we tethered IUD to uterine fundus using our device. The suture was completely absorbed by the 6-week time point, which is typical of puerperium, after which the IUD was removed. The IUD neither migrated within nor perforated the uterus during the study. This is promising because the baboon's uterine cavity is smaller than that of an average-sized adult human. Our initial study appears feasible. A longer study with more robust control will provide more definitive results about long-term safety and efficacy of our device and method. Thank you so much for listening.